Hello, everyone. Today we're going to talk about how we can identify systems of linear equations with no solutions. Okay, so graphically, what does it mean if a system of linear equations has no solutions? It means that the lines are parallel, so that the two lines basically they have the same slope, but they have a different y-intercept. So if your equations are in slope-intercept form already, it's pretty easy to tell this. It's pretty easy to look at the coefficients of x and notice that they are the same, and to notice the b-values, the y-intercepts, and notice those are not the same, and identify that as as a system of linear equations with no solutions. However, sometimes we're not given that, right? Sometimes we're given this form, for example. Both these equations are in standard form, and so it's not really as obvious what the slopes are or y-intercepts or things like that. So what are some other ways we could tell as well that the system has no solutions, also known as we have two unique distinct lines that are parallel in that case, that will never ever meet? Well, one way is we could start to do the elimination process. We could say, well, it'll eliminate both variables. If we were to multiply this equation by 2, this first one here, we would get 6x plus 4y equals 20. And then over here, we have for the bottom equation, if I just copy it down, 6x plus 4y equals 25. You'll notice if we were to subtract these, we would get 0 on our left, right? Because 6x cancels with 6x, 4y cancels with 4y, but 20 minus 25 is not 0, it's negative 5. And so we get something that's not true. So regardless of what x and y might be, it's never true that 0 can equal negative 5. Or another way to look at it is it can't be true that 6x plus 4y is 20, and also simultaneously in the same question, 6x plus 4y can be 25. It's not possible to have that be the case. It can't be two different things. It's either 20 or it's 25. And that's depending on which of these lines we're looking at. How else could we do it? We could also use substitution as well, and do it that way. I wouldn't recommend that with this particular problem, though. It would take a lot longer, but that is another way we could do it. And we would also, if we were to do that, end up with some nonsense at the end, like 0 equals negative 5, or something else that is equally untrue. All right, let's take a look at this second one here. So this second one here is a little bit easier to identify because we can notice, one thing we can notice here is that, oh hey, slope is negative 3 over 2 for both, but the y-intercepts are different. One of these is 10 and one of these is negative 7. So that's even something we could notice right off the bat of these are parallel lines, and parallel lines have no real solution. So therefore, no solutions, right? Just based on that. Let's say that's not your favorite way of doing it. Another way we could do it is we could use substitution. If we use substitution, we would get negative 3 over 2x plus 10 is equal to negative 3 over 2x minus 7, giving us 10 equals negative 7, which clearly is a bunch of nonsense, right? That's not true, so therefore there's no solutions, because no matter what we plug in for x or y, there is never going to come a day where 10 is equal to negative 7. That doesn't make sense. Or we could use elimination. We could subtract these and end up eliminating y and eliminating x, and then getting 17, right? We get 0 equals 17, which is equally nonsensical in comparison to 10 equals negative 7, right? In fact, if we just add 7 to both sides, with 10 equals negative 7, we do get 0 equals 17, which is also a bunch of nonsense, right? And so if we start with the substitution or elimination methods when there's no real solutions, we're going to end up with something, rather than something that's always true the way we did for infinite solutions, we're going to end up with something that, regardless of what x and y are, is never true. It doesn't matter what I try to make x and y be equal to, it will never be true that 10 is negative 7 or that 0 is 17. Those things are just always false. So there we go. Those are some ways we can identify when we have a system of linear equations with no solutions. Now, do remember this is a relatively, it does happen, but it's a relatively rare case. Vast majority of the time, there's exactly one solution. However, it is also possible to have no solutions, right? In the event that it's parallel, that we know there's no solutions then, or to have infinite solutions in the case that the two lines that we are given actually turn out to be the same line with the same slope and the same intercept. All right, good work today, everyone, and we'll see you for the next one.